In this video, we're going to look at capacitors. A capacitor is a device that stores electrical energy. It's not like a battery. It's not a source of charge, and so it's not a power supply. It soaks up power and releases it when there's less power. This is a symbol for a capacitor. There are a few variations of this symbol, and these variations tell us about the specific characteristics for the capacitor for that circuit. Substituting a different capacitor to what the schematic says could make your circuit not work. But for our introductory session, it's not going to matter too much. Capacitor's electrical size is measured in farads, and that's written like this. It uses an F or a UF or a PF. The F stands for farads, the UF stands for microfarads, and the PF stands for picofarad. A 1 farad capacitor is really a large capacitor, so it's quite normal to use a value between 0.1 of a microfarad and 500 microfarads. But sometimes you might want to use these really tiny capacitors, these picofarad capacitors. And this is a very small value of capacitance. At an introductory level, I think of capacitors like this. Big capacitors discharge a lot and maybe a bit slowly, and small capacitors discharge only a little but quite quickly. Of course, that's oversimplifying all types of characteristics of capacitors, but just at an introductory level, that's fine. There are 3 characteristics of a capacitor I'd like to quickly examine. Some capacitors, like these ones, are polarized. See this stripe? It's got a negative leg. And the fact that it's polarized means that it's got a positive and a negative. It matters which way you hook these capacitors up. If you look at the side of a capacitor, you can see the farad rating of the capacitor. You can see this one, it's rated for 10,000 microfarads. And if you have a look on this capacitor here, you can see that there's a maximum voltage rating. This one is rated to 50 volts, which means that if you're only putting 5 volts through it, it'll work just fine. But if you put 50 volts through it, well, that takes it to its limit. And if you put 51 volts through it, well, it'll probably work for a while, but it will die eventually. Now, if you apply too much voltage to them, they'll probably break down slowly over time. If you hook up a polarized capacitor the wrong way, well, you can get a spectacular failure, like this. Now, there are lots of different types of capacitors. These ones are electrolytic capacitors, and it's quite common to see them for values more than 1 microfarad. Then there's these ones. These are ceramic capacitors, and you normally see and use ceramic capacitors for values less than 1 microfarad. So let's use a capacitor. Here I've got my unregulated power supply, and we've used this one before. We can see that the power coming into here is all over the shop. It's DC, but it goes up and down like a yo-yo. So let's see what happens when we hook up a little capacitor. This is a little 10 microfarad capacitor, and you can see straight away that it's leveled out the power. But it's a little bit more complex than that, because after all, there's hundreds of thousands of different types of capacitors. Let's put a little load on here. Here I've got a 5 ohm resistor. Ohm's law says that if the voltage stays the same, as the resistance goes down, the current goes up. So at the moment, with a small value resistor like this 5 ohm resistor, there's going to be a fair bit of current try and flow through this. And when we hook it up, you can see that the power's all over the shop again. So what we need to do is we need to put a bigger capacitor on here to cope with that load. So what's that I hear you say? Why don't we just use really big capacitors all the time? Well, it's not that simple. Sometimes you might want just the right amount of capacitance for your circuit, where too little causes problems like this, but too much causes strain on other parts of the circuit. Some capacitors for your circuit might be too small, some capacitors for your circuit might be too big. What you need to do is find the capacitor that's just right for what you need to do.